Namaste. Welcome to the Indian Knowledge Systems primer course for children offered by Anaadi Foundation. In this lecture, we are going to look at squaring. We have already discussed that 8 arithmetic operations are considered to be the most foundational arithmetic operations in Bharatiya Ganita, because all transactions using numbers require these 8 arithmetic operations. In the regular common education, we currently study addition, subtraction, multiplication, and division as the 4 main arithmetic operations. Whereas in all ancient Indian mathematical traditions, we considered 8 fundamental operations called parikarmashtakam. What are those 8 operations? The word parikarma, it means arithmetic operation, and ashtaka means a group of 8. Sankalanam is addition. Vyavakalanam is subtraction. Gunanam is multiplication. Chedanam is division. Varga is squaring. Vargamula is square root. Ghanam is cubing, and Ghanamulam is cube root. So Vargam, Vargamulam, Ghanam, Ghanamulam. Here we are going to look at Varga, the squaring operation. This operation has been known ever since the Vedic era itself in the Indian mathematical traditions. We earlier saw the Shulba Sutras, and geometrically to find the area you had to know this operation. So the clear meaning of the term Vargaha, the Vargaha or square, has been given by Aryabhatta in his Aryabhatiya, written in 499 CE when he was just 23 years old. He says, Vargas samachaturashraha phalam cha sadrishadvayasya samvargaha. Vargaha samachaturashraha. The term Vargaha can mean two different things. One, it is a samachaturashraha, means a 4-sided figure which has 4 equal sides. Samachatura ashraha, 4 equally sided figure, which is a square. And its area, it can also denote its area, or it can also denote the result of sadrishadvayasya samvargaha, the result phalam of 2 equal quantities. Sadrisha means of the same kind, dvaya means 2. So sadrishadvaya means 2 equal quantities. Sadrishadvayasya samvargaha means product of 2 equal quantities. It means that A into A can also mean A square. Today the very term square is also meant to denote two things, right? Which is the geometric object of square, or this operation called a square, where for instance 5 square means 5 into 5. You must appreciate that the same terms that were anciently used in Sanskrit came much later in the English usage as well. So the Sanskrit term for square is Varga or Kriti. The word Varga commonly means rows or class. In mathematics, it denotes the squaring operation and also the square figure or its area. Now, squaring is a special case of multiplication where the gunya and gunaka are the same. The multiplicand and the multiplier are the same. In modern mathematics, we write it by denoting 2 in the right top here like this, right? This notation is called power or exponent of a number, right? So how to calculate it easily for large numbers, for which Bhaskaracharya in Leelavati gives a beautiful verse. Leelavati was written by Bhaskaracharya in the 12th century CE. And there he gives this wonderful verse to capture how to do squaring. Actually, Bhaskaracharya gives 4 different methods in which we shall now learn the most generic technique. Okay? Let us chant the verse. Samadvighatah kritiruchyateth स्थाप्योऽन्त्यवर्गो द्विगुणान्त्यनिघ्नाः स्वस्वोपरिष्टा च तथा परेङ्काः त्यक्त्वान्त्यमुत्सार्य पुनश्च राशिम्. He tells a particular technique. This is based on some algebraic identities. He tells there is the Antyapada and Adipada. So he says, first he defines what is Vargaha or Kriti. He says Samadvighataha, product of two equal quantities is Kritihi. It is said to be Iti Uchyate, right? So it is said to be this Kriti, another term for Varga, right? To calculate it, he says Antyavargaha, Stapyaha Antyavargaha. So position the square of the last digit above it and then multiply the last digit into 2 and the rest of the digits and place them in the respective places above them. So this as a verse, let's understand it as a technique. Before that, let us appreciate the algebraic identity behind this. A plus b the whole square is actually a square and 2 times a into the rest of the digits. Only b is there, right? So a square plus 2ab, then b square, then rest of the digits 2 times, no other digits are there, so only till b square. Then when it comes to 3-digit number, the identity looks like this: a plus b plus c the whole square. So it is first a square, 2 times a into b, and then 2 times a into c. This comes here first. Then it's b square, then 2 times b into c, the remaining digits. Then c square. After that, there are no more digits to do twice that. Now a plus b plus c plus d the whole square will be a square plus 2ab plus 2ac plus 2ad, and then b square plus 2bc plus 2bd plus c square plus 2cd plus d square, and that's this expansion. This is a very simple way to remember it, and in an earlier lecture we have seen the geometric demonstration of the same given by Indian mathematicians. Now we are going to use this principle to find the squares of numbers. Let us say we want to find the square of 357. You want to find the square of 357. So let's do 357 square. This is our objective, to find this. So first write 3, 5 and 7 here. Right? Now you see we have written 3 here, 5 here, 7 here. First we should do 3 square and write above 3. Okay. So as many number of digits are there, leave those many lines here and then write 3 straight above 3 square straight above 3. 3 square is 9. So first we compute that a square. We get 3 into 3 is 9. We write that in the column straight above 3. Now you remember we have to do a square, 2ab, 2ac, right? That's what we are going to do now. Next we are going to do 2ab. So we are going to do 2 into 3 into 5. 2 into 3 is 6, 6 into 5 is 30. We have to write it above the column of 5. 0 here, units place. Then the next place goes to the next column. Okay. First we wrote 3 square straight above 3. If any extra digit is there, let it go to the tens. If there is a tens digit, let it go to this column. Now we have done 2 into 3 into 5. And that goes straight above 5 column. And put the units digit here and the tens digit here. Now you might have guessed the next step. It is 2 times 3 into 7. And that has to come where? Right above the 7 column here. 2 times 3 is 6, 6 times 7 is 42. So we write 2 here and 4 here. Great. Now we have done a square plus 2ab plus 2ac. Now we have to do another step. This is what it is said in the verse by Bhaskaracharya. Tyaktva, having dropped this first digit, slide all other digits here. Drop this first digit, slide these digits one place here. 5, 7. Later, I will explain the importance of this sliding or the mathematical significance behind it. Now, what are we going to do? We are going to drop 3, take the other 2 digits and slide them one place. 5, 7. You have slid them here. Now 5. Right above 5, now we should do 5 square here. Right above 5, units place should come here, tens place will come here. This will be our B square. Right? 5 square. Now we have to do 2 into 5 into 7. That will come right above 7. 2 into 5 is 10 plus 7. Sorry, 2 into 5 is 10 into 7 is 70. Right? 2 BC. 7, 0. So put 0 here and 7 next to it. Right? Then the next thing. Right? Then the next thing. There are no more digits to do here. Right? 5 square plus 2 into 5 into 7 is over. Next thing, slide one more place and then put 7. Drop 5 and put 7. You see there is this sliding operation. What do we learn in the sliding operation? Once you do square of this number and 2 times all this number, drop that number and slide the rest of the number. Now we have done square of this number, 2 times this number. So drop this number and slide the rest of the number and we end up with 7 here. Okay. Now right above 7 do 7 square. 7 square is 49. So write 9 here, 4 here. Now forget all these 3 rows which are our reference rows as to where to write the numbers. Now if you add the rest of the columns, 9 you get 9. 4 plus 0 you get 4. 7 plus 5 plus 2 which will be 14. You write 4, carry over 1. 1 plus 2 plus 4 which will be 7. Then 3 plus 9, 12. So write 2 here, carry over 1 and 1 comes here. So 127,449. 1,27,449 is the square of 357. To revise, what did we do? We first took 3 and its square we wrote here. 3 times 2 times 5 here. 3 times 2 times 7 here. Then drop 3, slide the rest of the numbers. 5, 7. Above 5, write first 5 square. Then 2 times 5 times 7, we write 70 here, above 7. Now 5 is over, drop 5, slide. Now you got 7. And then right above 7, you write 7 square, 49. These are our reference rows, so you skip them, add the rest of the rows and you will get the final answer. One more example. Now let's say we want to find 475 square. 4 square, first we write 16. Units place right above 4 and 1 in the next spot. Next step, 4 times 7. 4 times 2 times 7. 4 times 2 is 8. 8 times 7 is 56. Write 6 here in the units place and 5 gets carried over to the next place here. Now 4 times 2 times 5. 4 times 2 is 8. 8 times 5 is 40. You write units place here. Tens place gets carried over here. Now all operations 4 square and all multiples of 4 are over. So drop 4. Slide all the digits, rest of the digits one place. So if 7 was here, now next time it goes here. So you've got 7 here, 5 here. Again do 7 square, 9 here, 4 here. Right? 7 square is 49, units place right above 7. Then 7 times 2 times 5 will be 70. 14 5s are 70. So you write 0 here, units place. Tens place here, 7. Now squaring and multiplication of 7 with all other digits are over. So drop 7, slide the remaining digits. Remaining digit we have only one digit. So you write 5 here, 5 square here, right above 5. No more digits to multiply, so you stop the operation here. Skip these 3 rows. These 3 rows are only reference rows for positioning. Sum total all the other columns. 5, return 5 here. 2 plus 0, 2. 7 plus 9 plus 0 is 16. Write 6 here, carry over 1. 1 plus 4, 5. 5 plus 4, 9. 9 plus 6, 15. Write 5 here, carry over 1. 1 plus 5, 6. 6 plus 6, 12. Write 2 here, carry over 1. 1 plus 1, 2. 2, 2, 5, 6, 2, 5. 2,25,625 is the square of 475. This works for any number of digits. All you'll have to do is square from the last digit right above it and keep sliding when you have completed all the multiplication of all the other digits with the last digit. Why is this sliding important? You see, 475 is made of 400, right? 400. 4 times 100. 100 square will be 10,000, right? So it will be 0, 0, 0, 0, 1, right? So that's why the sliding helps us manage the place values. Now if it is 2 times 400 times 70, 400 into 70 will have at least 3 zeros, right? Because 100 into 10 will have 3 zeros. So you slide them and you write here. That's the logic behind sliding. You do not worry about this logic per se, but follow these steps carefully. Write the digits, start from the last digit, write it square, multiply 2 times the last digit into every other digit, write it respective to its places. Then drop this digit, slide. Write the square of this digit, 2 times this digit into all other digits, only 1 digit is left, you do this here. Then drop this number, slide. Write 5 square here. A very intelligent way and a beautiful way in which we can calculate the squares. Dhanyavadaha. Namaste.